We're going to start off with some vocabulary and notation. We're going to first define one-sided limits. If I go off screen, can you guys let me know? Okay. A one-sided limit is the calculated value or does not exist of a function from only one side of a graph from only one side of a graph. That means we're going to be coming from the left side or the right side of the graph. So now we have specific ways to write and calculate when we're coming from the left. Remember how I tell you to go from the left to the dot or to the line and then the right to the line? Now we have an extended definition or an extended, trying to think of the word, extended definition, extended notation. I'll come up with it in a second. So keep this in mind. When we ask you for a one-sided limit, it is only coming from one side of the graph. But Miss Santana, how do I know which side? Great, we have notation. Can I move down? Right here? I know some of you are still writing. Can I go right there? Okay. All right, so we have notation for this. So the first notation we have is, what color am I? This one? No. First notation we have is the left side limit. The left side. The left side limit is as follows. It is the limit as x approaches a from the left. This little negative sign, and you'll see in a second, a plus sign, it's way different from just what we did last week, where it's just an a of f of x is equal to b. So again, this negative sign means from the left. Am I off screen? Okay, thanks. That negative sign means from the left. So if negative sign means from the left, what do we think is going to be from the right? What other sign do we have? Positive. I see some of you mouthing positive. You guys can speak up, right? Right side. So the right side is the limit as x approaches a from the right of f of x is equal to c from, why didn't I use different colors? The right. Now you notice that I use two different variables to show the value. That is because it doesn't always have to be the same. So I use two different variables to show the value. Okay. Am I going too fast? Are we sure? Can I get a thumbs up if you're done writing this so I can move on? Okay. I'll give you another minute or two. Ready? Okay. All right, next thing we have is called the formal definition of a limit. Formal definition. I think I spelled that right. Of a limit. Formal definition of a limit. Because in math, we need a definition. Like, we can't just say these things exist because they exist. We need, do you need to go get water? Yeah, go ahead. We need some mathematical way to prove it exists. So I don't know if in geometry you did proofs. Did you guys do proofs in geometry? Where you had like, if right angle is 90, no, you don't remember? Okay, forget it. That was 2 years ago, I guess. So we're gonna get two different things here. We're gonna get words, okay, which you'll use to form a basis of an explanation when we actually ask for words in an explanation. And then you're gonna get symbols. The symbols have to be exact. I'll get there in a second. The words can be a summary as long as they make sense. Am I interrupting? Okay. So in words, for a limit to exist, oops, I spelled it wrong, exist, which means that it has a value. You good? Okay. The left-hand limit and the right-hand limit, oops, must approach the same value. Make sure you sign up. So, remember when Mr. Esquivel and I are talking about a limit and we're having you go from the left and the right, and we say, does it get to the same number? Do you circle that same number? That's what it means. To go from the left and the right, you have to get to the same value. And that's what this means in order for the limit to exist. Again, from the left needs to get to that same number, from the right needs to get to the same number in order for it to exist. If it doesn't get to that same number, what is it? D and E. It's D and E, does not exist. Okay? That's what that means in words. So we're bringing together what we did last week to this week. We're just extending it. Okay? I'm going to move that up. Does everybody have it at least to right there? No? Yes? Nobody's answering, so I'm just going to keep going. So now we have notation. This will need to be exact when we are asking you for explanation using symbols, or mathematical notation. It has to be exact, okay? I'll get to what I mean by exact. Hold on. sorry, I moved ahead of myself. I'm going to give you the definition in notation, but then tell you what it needs to look like exactly. So this is the definition in notation. So if the limit as x approaches a from the left of f of x is equal to b, can we see that color? Okay. And the limit as x approaches a from the right of f of x is equal to b. So from the left, from the right, think of a number line. To the left of 0 is negative, to the right of 0 is positive. That's where this comes from. Then, the limit as x approaches a of f of x is also equal to b. I'll move up. Is that good for those of you who are like craning your necks? Can you see? No? Okay. We're almost done with notes, and then we will go to examples. Okay. This part right here, can you star it? Can you circle it? Can you highlight it? This is what we are going to be looking for when we're asking for mathematical notation. This is what we're looking for. This is how you're going to write it. Okay? I'll move up. Can I move up there? So in mathematical notation, we're going to write the limit as x approaches a from the left of f of x is equal to the limit as x approaches a from the right of f of x. Therefore, these three dots in math mean therefore. So you're going to see us write this a lot. Because again, I told you last week, in math we don't like to write tons of words. We create symbols for everything. This means therefore. The limit as x approaches a of f of x is equal to b. So again, this is symbol or notation explanation. This is what we're looking for. Questions? Do you need this? Okay, when you're done, take out your do now. Put it at the top because I want to show you how it works with a problem that we already have. All of it or just this one? I think I need the last one. The last one's right. Anybody need more time to write this down? Are you good? Ready? Oh. Samuel, let me know when you're ready. Huh? You good? Okay. All right. So let's look at the do now. I'm gonna look at we're gonna look at B and C. Okay, we're gonna look at B and C. Okay, so I'm gonna try to show you this. Okay. No. Sure. Okay. So we're looking at -2. Here's -2. Okay? Mathematically, in order to see if a limit exists, we need to go from the left. So this side is the left, right? I mean, correct? This is the left of the graph. Is it okay if I do it this way so you guys can see? So I'm going to move until I get to this point. So this is the limit as x approaches 2, let me write that better, sorry guys. The limit as x approaches 2 from negative 2 from the left of f of x. And we found this to be negative 2. Any questions on that? Now we're going to go from the right. So I'm going to go here. So this is the right side. Bless you. This is the right side. This is the limit as x approaches negative 2 from the right. This is also negative 2. So because these two things, like we said before, like we're getting to this same point. We go from the left and get to the point. We go from the right and get to the point. Then the limit is negative 2. Does that make sense? For those of you who are still struggling with the graphs, the point of this lesson is for you to see it in another way. Okay? Questions? Okay, let's do 0 then. So here is 0. If I approach 0 from the left, so I'll just do it up here. This is the limit as x approaches 0 from the left of f of x. This, excuse me, is negative 2. No, what is it? Sorry, 0. Let's look at the wrong thing. 0. When I approach it from the right, I get negative 1. The limit as x approaches 0 from the right. Can you see this? Thank you, whoever is talking. Because these two things don't equal each other. What happens? Yeah, I see some of you shaking your head. The limit doesn't exist. That is the formal definition. Because this limit on the left does not equal this limit on the right. That is why it does not exist. Are there any questions? Are we sure? For those of you who were struggling last week, I hope this helps. If it doesn't, please let us know. I have office hours tomorrow morning. Okay? Office hours tomorrow morning. When you're done writing this down, take out the sheet that Mr. Esquivel passed out. We're going to go over the front, and then on the back, you're going to work with your group. And then tomorrow we'll go over the answers. Yes. Okay, I may be going a little quick, just so I make sure that you have time to work in your group on the back. But if I go too quick or you don't understand me, please stop me. Don't be afraid to stop me, okay? Or ask Mr. Esquivel, just don't stay quiet, okay? All right, so let's look at the first one. I'm gonna try to get everything in here, but you have, okay. So for the first one, this is negative 10 from the left. Remember, this minus sign means from the left. So I'm going to draw my line at negative 10. And I'm only going to look at that left side of the graph. Okay? I don't care about the right side. Wake up. Wake up. Wake up. I don't care about the right side right now. All I care about the left side is because of that left symbol, okay? So, as Mr. Esquivel said, the arrow goes on forever. So, I'm going to draw a line and circle that point. that value is negative 9. Are there any questions on that? Are we sure? Did I go too fast? Did that help? I know some of you are squinting. Let me zoom in a little bit. So now I'm going to go to the right side. And I'm going to circle that number. That's also negative 9. So now what you want to do is you want to compare the left and right. You don't want to do this again because we have a definition now that tells me something. That definition tells me if these two things are equal, then this number is also that. So are these two things equal? Yeah. What is this then? What is this limit? Negative 9. I'll say it again. We now have a definition that says, you don't have to recalculate it. We now have a definition that says, if these two limits are equal, the left and right side, then the limit exists, like the regular limit exists. Does that help? Are we sure? Yeah.
So if it's negative 9 for the left side, it's always going to be the same thing for the right side?
No. You'll see when we get to an example like that, okay? Good question, though. So let's look at negative 2 now. I'm going to draw a line at negative 2, so look at this example, okay? Again, I'm going to start on my left side. I don't care about the right side right now. And I'm going to go, can you see? Can you guys see this? Am I covering it? I'm going to go, and I'm going to circle this. That value is negative 6. Wake up. Questions on that? Now, I'm going to go from my right side and circle that value. That value is negative 2. Do these two things equal? Bless you. So, if they don't equal, what is this limit? D and E. So, do you see that now? These two things are not equal. So this does not exist. Questions? Did that answer your question? Okay. All right. Now let's do 0. I'm going to do this a little quicker. You tell me if I go too quick, if you need me to explain more, okay? All right, so here's 0. I'm going to go from the left. Circle that number. I'm going to go to the right. Circle that number. Sorry, I forgot to write it down. Let me zoom out. Negative 3. Negative 3. If these are equal, that means this limit exists and is that value. Did I go too fast? Are you sure? Anybody? Okay. All right, now we're going to do 6. I'm going to go to the left. That's negative 6. I'm going to go to the right. That's negative 8. Are these equal? So then what's the limit? D and E. Questions? Okay, now again, you will not get full credit if you don't answer the 2 questions on the level 3. It doesn't matter if you got all this right. You'll get a 2.5. Capiche? Okay, you'll get a 2.5. You need to write these. Okay, it says explain your answer to 1I. So we're looking for this one right here in words, not notation. So we want to use words. You can say the left side limit. I'm just going to abbreviate LSL, left side limit, okay? And right side limit, approach, can't spell, the same number. I'm sorry, value. Let's use correct terms. Therefore, the limit is negative 3. Does that make sense? Did I go too fast? Are we sure? Okay. All right, last but not least, we need to explain 1f. So that's this one right here. And this is in symbols. You see how it says mathematical notation. This one said mathematical vocabulary. That's why I used approaches. That's why I used value. Okay? Instead of number. So this would be as follows. The limit. And you want here's the hint. You want to use these two notations right here. Okay? You want to use these two notations, the left side limit and the right side limit, to help you write the notation. So the limit, as x approaches -2 from the left of f of x. What does this symbol mean? Let me zoom up. What does this symbol mean? Does not equal. And we know that because these two things are not equal, right? The limit as x approaches 2 from the right of f of x. Therefore, the limit as x approaches 2 of f of x, oh, -2, sorry, -2, does not exist. Oops, my bad. Oh, sorry. Questions? Questions? Okay. We have about 15 minutes of class left. Flip over when you're done and work in your group. We'll come around and answer any questions that you have. But work in your group and yeah, questions? All right. Go ahead. I'll leave that up for those of you who need it. And